Welcome to Code Chrysalis' 13th Big MiniConf. This event is about passion, technology, and geeks, 12 of them. Today, we have two tracks happening simultaneously, one in Japanese and one in English. 8 weeks ago, those 12 geeks joined a full-time coding bootcamp. And this coding bootcamp. And during those 8 weeks, they have been through a fast-paced course where they quickly learned new technologies and developed software products on tight deadlines. On top of that, they were also asked to research a technology they were passionate about and give a presentation about it. You're about to witness that presentation. So come closer and listen to passionate people geeking out about technology, how fascinating it can be, and its impact on your life and our world. So first, you hear about computer science fundamentals through the lens of game emulators. Please give it up for Bryson.
Hello. Can you hear me okay?
Yes, perfect. All right.
So my name is Bryson Bennett, and I love video games. My topic today is emulators and computer science. How many people know what an emulator is? And how many people have used an emulator? Well, I guarantee that every single one of you have used an emulator and just doesn't know it. Emulators are everywhere. They are in our OSs, our phones, our cars, and even our printers. Yes, I'm serious. But those probably aren't what most people imagine when you hear emulator. What is an emulator? Okay, for those who don't know, an emulator is a piece of software or hardware that is written to behave like a different system. When most people hear emulator, they probably imagine this: console video games played on PC or other devices. Although I can't imagine it ever being fun played on a touchscreen. Yuck. I grew up using these to play Mario, Zelda, Final Fantasy, and Pokemon games before they were released in America. For the tech talk today, this is the type of emulator I will be talking about. Initially, I wanted to write an emulator and give insight in how to write one. Well, it turns out it takes a long time to write an emulator and even longer to get to the technical level where you can write one. The number one resource I used to write this was a 7-hour series a guy made documenting how he made it, and I still only understand about half of it. He spent months making his emulator, so I couldn't hope to emulate him. I since then have realized the error of my ways and changed the tech talk accordingly. But his videos were greatly helpful, as well as his source code filled with lots of helpful comments. Thank you, one lone coder. Watching his videos along with nesdev.com and doing lots of other research on the topic has given me a more complete understanding of computer science, and that is now what I've shifted the main topic of my tech talk to: understanding computer science through the lens of an emulator. To emulate, you must first know what you're emulating and what hardware and software you're trying to emulate. The NES, or Famicom, is made up of the following major components. There are more than this, but these are the big ones, and inside these are also smaller components. Understanding how these major components work inside the NES will also help you understand how any computer works, because that's what the NES is, a computer. It's got a CPU, RAM, input, output, etc. These are the CPU, or central processing unit, RAM, random access memory, APU, the audio processing unit, PPU, pixel processing unit, and there are other bits and pieces, but and also the bus that connects them all. First, I will start with the most important piece, the CPU. Not all processors are created equal, and the NES CPU is called the Ricoh A2A03, and it's based on a very popular processor called the 6502. It's 8-bit, which means that it can only read 8 bits of information at a time, which also means that each bit is very important. For comparison, most modern processors are 64-bit. When a CPU receives instructions, it sends the instructions to a certain range of values. Each of the previous slide's components respond to a certain range of values coming as instructions from the CPU. When writing CPU emulation, it's important to read the instructions as they come and write it in a way that imitates the original hardware. There are a total of 256 different types of operations the CPU can do called opcodes. These are things like writing to certain memory address, fetching data from memory, basic math, etc. I believe the NES only uses about 80-something opcodes, so that's nice. All instructions to the CPU are either 1, 2, 3, or 4 bytes, and the instruction is included in the first byte. The first byte sends which opcode to run, and if that opcode requires more bytes, the opcode essentially tells the CPU to wait for more bytes to come. The cycle goes like this. The CPU reads the first byte, which corresponds to an opcodes table. The opcode tells the CPU how many more bytes it needs to do a task. And the CPU reads that many more bytes and executes the command. And then the next cycle comes. I liken it to looking up instructions on Stack Overflow and copying the code. This is a visual representation of an opcodes table. The table tells you where the opcodes can be found, how many bytes it needs to execute, and what operation it performs. Like the CPU first byte points to A8, it says transfer A to Y. And it only takes 1 byte, and it takes 2 cycles to complete. The programmer would have to write a function that does this already, and already know A and Y and the code cycles. By the way, A and Y are registers, like tiny storage, but I won't get into that for the interest of time. In general, the CPU interacts with the ROM and sends data to the PPU, RAM, APU, etc. The NES CPU can address up to 64 kilobytes of memory. When the CPU sends an address to the bus sends the data to whichever component is on the memory range. Now, the NES does not have 64 kilobytes of memory, so if it writes or tries to access an address above what it's capable of, nothing happens, and the programmer knows who's done something wrong. Similarly, there are also components here which can be only read or only written or both. Like the RAM can be read or written, the APU can only be written, and the ROM can only be read, read-only memory. If you look closely at this, the first 2 kilobytes of data sent from the CPU on the bus interacts with the RAM, and the next address from 16384 to 16407 goes to the APU. If the CPU sends to the address 8192 to 8193, it goes to the PPU. The PPU also has its own bus that acts similarly to the CPU, and it interacts with the components on its own bus in a similar manner. This is confusing, but if you think of it like an array, and if you write to the X index in the array, it will do something with the RAM. And if you read from the Y index, it will do something with the cartridge. You might look at this wonderful thing I made in MS Paint and say, that doesn't look right. The numbers don't add up correctly. Well, the RAM actually exists on 4 times as many addresses as it can be used, and they're mirrored. There are reasons for this, but again, in the interest of time. Now, I'm going to go off on a bit of a tangent here, but trust me, it's important. This was integral to me understanding CS better. To read and write instructions, you need to be able to take out important bits in each byte and set important bits in bytes. Based on what you write, the other components will take the instructions. Also, an interesting thing, 8 bits are a byte, but 4 bits are a nibble. Hexadecimal is often written in nibbles. The processor can only handle 8 bits, 1 byte of information at a time, which means parsing those bits is really important. Let's say the CPU sends instructions to the PPU, and the PPU reads the first 3 bytes in blue as values. They read the red bytes as a state of which 4 exist, and the pink ones are just simply flags. It's important to pinpoint those bits to extract the data you need, but finding those bits values isn't as easy as it sounds. That's where bitwise operations come in. When you're interacting with bits, bytes of data, you will be doing it when making emulators. You will be using bitwise operations. There are 6 primary bitwise operations, and they allow you to change bits in a byte. These are shift left, shift right, and, or, exclusive or, and not. Shift left and right are pretty clear. Let's say you need to set a flag on the 4th bit. You would write 1 on the 1st bit and shift left 3 bits. And same for right. Let's say you need to extract the bit on the 5th position. You would shift right 4 and read the byte. And is a bit more complicated, It compares 2 bytes and results in a byte where ones only stay the same if both bits are ones, like in the GIF. Let's say you need to know the first 3 bits of data. You would create a nibble like this, and then you would do an AND operation, and the result would be the bits that you're interested in. So like the one that you want the data from would be 1, 1, 1, 0. You would write 0, 0, 0, 0, 1, 1, 1, and the result will be the 3 bytes that you're interested in. Or is kind of the opposite. It works by setting bits to 1 if either bit is 1. For example, 1, 0, 1, 1, 0, 1, 0, 0 would result in 1, 1, 1, 0. Exclusive OR, little hat, is a toggle. Pretty simple. If all of these are 1s and you want to switch this byte, you would do it like this, 0, 0, 1, 0, 0, 0, 0, and the result will be the same byte, but that 1 bit toggled. Not just flips everything. It's really simple. 0s become 1, 1s become 0s. Memory. The NES only has 2 kilobytes of usable RAM. It holds temporary game data that is accessed by the CPU. This is pretty easy to emulate. I've seen many places represent it as an array and writes to indexes on the array. It works just like regular memory for use. CPU takes data from the ROM or the cartridge and writes it to an address in the memory for easy access later. Think of it like putting certain data in an index in an array. I have a very cool emulator here that is running from Super Mario Brothers. And there's a memory tool right here, which will show you memory reads and writes in real time. So I could scroll and look at each memory address inside the RAM, and I could see it changing in real time. So this is what it looks like. The PPU. Think of it like an ancient prototype video card. It holds high-level graphics data, 2 time tables, 2 pattern tables, palette info, and OAM, or current sprite RAM. It also reads data from the ROM to write to the screen. It's much faster than the CPU and takes instructions from the CPU. First are pattern tables, sprites and tiles. This is what it looks like, when it's visually shown, but it does not hold color information. And it's usually for sprites. The pattern table is 1 for sprites or moving things on screen, and 1 for tiles, usually the backgrounds. Also, OAM, or object attribute memory, it has 64 sprites and information where to input that on the screen. Although the NES can only have 8 sprites on the screen at a time, this is a known limitation, the NES, and most game programs around this. If you've ever played an NES game and the sprites were flickering, it was because there were too many sprites on the screen. If you write to an emulator, you can remove this limitation. Now I will go back to the same emulator, and I can show you what it looks like on memory. So this is the current palette and sprite and tile information being read by the NES. And this is the OAM. So once Mario moves and another sprite comes on screen, you'll see it change in real time. See? I think that's neat. Now we have color palette RAM. Contains information about how to color sprites and background. For example, rather famously, the tile for clouds and wishes in Super Mario Brothers are the same, just colored differently. The PPU looks at what tile is supposed to be outputted and then what color palette is supposed to follow. There are 8 addresses, 1, 2, 3, 4, 5, 6, 7, 8. And so it has all addresses have 1 universal background color, so blue for here because everything's going to be blue. And these can change. 4 which are for tiles and 4 which are for sprites. Each palette has 3 colors and 1 background color. And I can show you that as well in a really cool demo. So this is the palette viewer. And if I click on one in the emulator, I can change it in real time. which I think is neat. And I will reset that. And finally, name tables. Name tables are where the previous information is supposed to be mapped to the screen. There are 2/4 name tables. It is like this because they're random mirrored. And this one would just be easy to explain with a demonstration again. The same game. And if I look to the name table viewer, this is what's being outputted to the screen, but this is what's being rendered behind the scenes. I'll let you wait for Mario to start moving. Cool, right? Next is the APU, or the audio processing unit. It's in charge of outputting sound. Its registers are mapped to 16.384 to 16.407. That's a very small area. I hope that gives you a glimpse into how many sounds the NES can make. And the NES has 5 sound channels, and these are for 2 are for melodies, 1 for bass, 4 makes sound like noise, and the 5th one makes percussion. On the NES, these are obviously made with hardware and with those limitations. For emulation, you would have to emulate those limitations just like everything else. Only certain frequencies and sounds can be created. And finally, ROM. Emulators are completely free, but downloading and sharing ROMs are not. To play ROMs in an emulator legally, you must extract the data for your own personal cartridge using a similar device to what you see on the right, which I've done. What is on a cartridge? CIC. This little guy here is DRM. Did you ever blow on a cartridge to try to get your game to work better? That's only because of this little chip here. If this chip didn't exist, you wouldn't have to do that. Also, don't do that because it actually makes it worse. For emulation purposes, this can be ignored. I believe one line of code ignores it or emulates it. We have character ROM, which it holds the patterns for the game graphics. It does not include color information. This was covered in the section for the PPU. It's like what I showed you. And PPU reads these from the ROM. And program ROM, this is usually 32 kilobytes plus of game data, usually sound data, game color data, and game execution data. And finally, the mapper. Mapper is very interesting. The mapper tells the PPU and CPU where the data they're trying to interact with is. The mappers are a way for the NES games to handle larger games than the internal memory actually supports. In the early NES games, mappers weren't necessary because the games were simple but a problem game. The CPU and PPU could only interact with a limited range of data, and gamers were demanding more complex and pretty games. The solution was a mapper to the cartridge itself. The mapper takes a signal from the CPU and changes what data the CPU and PPU can access. I'm going to show a different game for this. So if we look at our control character viewer, this is what's currently accessible and known to the PPU. But once I change scenes, that changes. So the PPU and the CPU don't actually know any better. They're just reading what the mapper tells them to read. So in conclusion, I hope my talk has given you all a better glimpse of how computers work in general and gives you an appreciation for the limitations people worked with in the early computer days, especially in relation to the NES. Thank you. Resources. These were immensely helpful. This one was just a cool video about just watch it, it's cool. And this is my GitHub. So thank you for listening. I hope this has been enlightful.
Thank you very much, Bryson. We'll have a quick break now. And from 1:30, we'll have Bilaal. That's not only research blockchain, but he also built his own. So stay tuned.
And she's in Hey, hello, and welcome to Why is Blockchain So Important and How Can I Build One? Hope you can hear me all right. My name is Bilaal Ukishima, and I'm Ghanaian, Japanese. And for those of you wondering what or where Ghana is, well, Ghana is a country in West Africa, and we are quite well known for chocolate. That's because we're one of the highest producers of cocoa beans in the world. And one funny thing is that as kids, we are taught that if you take a closer look at Ghana, it looks like the shape of a sack of cocoa. So as you can see here, kind of resembles a sack of cocoa, and so we are the chocolate country. So that's me. Now let's jump into the content of today's talk. First, I will talk briefly about why I chose this topic, and then I will give you a brief explanation about what a blockchain is. Then we'll explore some reasons why it is an important technology and what its applications are. In the next part, I will walk you through the process of building a very simple blockchain with JavaScript. And to help us visualize how blockchains work, I will show you a demo of the crypto coin I created called BBCoin. Finally, I will discuss some additional features that I'll be adding to my blockchain. So let's get into it. Why did I choose this topic? I'm sure many of you have heard a thing or two about Bitcoin and Ethereum and all sorts of altcoins for some time, but where did it come from? What is it? And how does it work? These are some questions we all have about the digital currencies, so I did some digging. After spending some time watching many videos and reading articles about crypto, I found out that a somewhat anonymous person or a group of people called Satoshi Nakamoto was the one who created a peer-to-peer electronic caching system on what we now know as the blockchain. So then my next question obviously became, what is a blockchain? And how was it created? After all, my research, I thought to myself, why don't I learn how to build a blockchain? And maybe that would help me understand them even more. So I did. So let's jump into what a blockchain is, and later I will take you through the process of making one. Blockchain. What is it anyway? Well, as the name implies, a blockchain is a chain of blocks that stores data within them. It acts as something we call a public digital ledger, and these are like an accountant's book, but open to the public. The thing about this digital ledger is that once a data has been recorded inside the blockchain, it can become very hard for anyone to change the data. So why is this so? Let's take a closer look. So here we have a block, and each block on the blockchain has one, some data within them, two, a hash that represents it, three, and the hash of the previous block. So the data stored inside a block depends on the type of blockchain. The Bitcoin blockchain, for example, stores transaction data, such as the from address and the to address, as well as how much was sent. Note that there could be multiple transactions that are stored on a block. Next, a block also has a hash. And this hash identifies the block and all the contents inside it. Once a block is generated, a hash is also calculated for it. As you can see, hashes are the output of a hashing algorithm and are always unique, and we can think of them like fingerprints. Example of hashing algorithms are the MD5 and SHA, which we will see its use later. Now, if someone changes something inside the block, it causes the hash of the block to change, and this means that it's no longer the same block. So hashes are quite useful in detecting changes to blocks. The third element inside each block is the hash of the previous block. So if you're already familiar with linked lists, the concept is quite alike. In a linked list, each node points to the next node in line, while in blockchains, each block points to the previous block in line. And as you can see here, this creates an effect like a chain of blocks, right? And block three points to block two, and block two points to block one, but block one does not point to any other block before it because it is something unique, and it's called the genesis block. As I mentioned earlier, because each block has a unique hash and it points to the previous hash, when a change happens to one of the blocks, the entire chain is affected. This, coupled with something we call mining difficulty, which we'll also see later, makes it really hard for someone to tamper with a blockchain. So let's see why it is important in 2021 and beyond. So 5 main reasons why the use of blockchain technology is spreading is because blockchain offers 1, immutability, 2, transparency, 3, security, 4, traceability, and 5, efficiency. So when we say something is immutable, it means that when you put something inside it, so in this case, data, when data is stored inside it, it cannot be modified or changed in any way. Transparency allows business to track every detail of the system. And security, as you saw, hashes are one type of cryptographic security, and there are also many types of validation checks within the system, and it makes blockchains really, really secure. Traceability, as you saw earlier too, if you change something within a block, the hash changes, and you would know exactly where the change happened. And that makes it easy to trace. And efficiency, well, since blockchains, the transactions on blockchains actually takes just a few seconds rather than weeks, we can do secure business transactions, especially international ones, really fast. And that is a huge advantage for most companies. So because of these advantages, companies are trying to adopt the blockchain system. So how is it used then? Well, we mostly know blockchain is used in cryptocurrency, but it's not only confined to that. In fact, it can be used in almost every sector, including real estate, manufacturing, healthcare, and client services. And there's way more, just like government and all that. But to delve into each will require a way longer session. So let's keep that for another time, or maybe you can read up on them. But for now, let's jump into what a blockchain is. So let's try building one. So in here, I have my blockchain file. So this is an empty directory, not entirely empty because I have the main.js here, but within the main.js, it's pretty much empty. We're just going to have this one line here, and this is going to import what we need for hashing later on. So let's start by creating the class block. Class block here, and within it, we're going to have a constructor which will take in some properties for this block. So we are going to have index, timestamp, data, as we saw earlier, and then the previous hash. And since we now have the data and the previous hash and all the information that would make up a block, let's initialize them. So we say this.index is equals to index. This dot timestamp is equal to timestamp. This dot data is equals to data. And this dot previous hash is equals to previous hash. Now, if you remember, a hash doesn't just have data and previous hash. It also has a hash itself. I mean, a data, right? The hash, the block has a hash for its own, the fingerprint. So we need to instantiate that hash. And to do that, we would need to make a method called calculate hash. So let's go ahead and put that as a method here. We say calculate hash. And here we'll be returning the hashing algorithm, the data with the hashing algorithm, right? So in order to do that, we need to import this here, which is the SHA-256, and we'll import it from Crypto.js. So I'm going to quickly open my terminal. Yep. So I'll do npm I crypto.js, and that would install the dependency. Oh, yep, here we have the dependency now, crypto.js within our packet.json. And close that. And now we can use the SHA-256. And we will give it all the data that it needs to use for the hashing. So we give it the index, we give it the timestamp, we also give it the previous hash. And here we'll give it the data, but since we want to stringify the data, because it's going to be JSON.stringify our this.data. And since the calculate hash function, the SHA-256 returns an object, I'm going to cast this as a string so that we can use that later on. Second. I think there's an error. Yep. And so here we can use the block that we have here that we've created with the hash, and we are going to create another class here called class blockchain. Blockchain, and this would also have a constructor within it. And this is simply going to be the chain, and the chain is going to be an array, right? The reason why it's an array is because each block is going to be added to the list. So in here, remember we had a Genesis block. So we would have to create the Genesis block ourselves. So I'm going to first put the method create Genesis block in here. And this would put the Genesis block in the front of the blockchain, right? And then we are going to, and then next we're going to create the Genesis block method. So the Genesis block method is simply going to be return a new block with index 0, and then the timestamp says, so we go say April the 1st, 2021. And then the data, since it's the Genesis block, I'm just simply going to call it Genesis block. And then the previous hash, Genesis block does not point to another hash, another block, so we wouldn't have anything. So we just put 0 here, and that would allow us to create the Genesis block, right? So now let's create two other methods that would help us, which is going to be get latest block. And this get latest block is simply going to return the chain. So this dot chain, the last element in the chain. So this dot chain dot length -1. Okay. And then we want to add a block to the chain. So we're going to do an add block method as well. And this add block method takes in a new block, right? And before the add block adds something or the block to the chain, we want it to do a few things before it adds that or pushes that. So we are just going to say new block dot hash, previous hash is equals to this dot get latest block dot hash. So it's now showing that the previous hash of this new block is the last block in lines hash, right? And then we're going to also give this new block a hash as well. So we'll do this dot calculate hash for this as well. And then once we've done that, we are able to push this into our blockchain. So we're just going to say this dot chain dot push the new block. Okay, now, So now that we've been able to hash the data that's given to this and then create a blockchain and create a Genesis block to start off the blockchain, let's try some testing. So I have here some pre-written tests for it. So I'm just gonna copy and paste that. Okay, here we go. So I instantiated a new blockchain with BBCoin, and BBCoin is just going to add this new block with index 1, and it's created on 2nd. I'll say this is the 3rd of April. Yep. And we just want to put an amount 10 coins, and then for the second one, we say 50 coins, right? And we will just console log the result into our terminal. So let me write node main.js. This calculate hash is not a function. Okay, so we have an error here, which says that this calculate hash is not a function, meaning that we'd have to check for it. Oh, this is the, yeah, this is a new block. It's not supposed to be this, but new block dot calculate hash. Oh, okay. So that fixed it. And let's see here. Here is our blockchain, right? We have the index 0 with Genesis block and a hash of this. And see how here in the index 1, the previous hash is the hash of the Genesis block, and that's the same here. The previous hash for this is the hash of index 1. So we have been able to create a blockchain right now, but it was quite easy to add blocks. So we'd want to add some sort of validation to make this a little bit more valid. So let's just do is chain valid as a method here. And this would loop over the chain. So for let I equals to 1, we don't want it to 0 because 0 is the Genesis block, and we don't need to check the validity of the Genesis block. So we're just going to say I is less than this dot chain dot length, and we just increase that plus. Yeah, and we want to show the current block, right? So we'll do current block. Once current block is equals to this dot chain, and since we have the index, we say I, and then we also have the previous block. This dot chain, and since it's the previous one, it's going to be I minus 1. Now we have the current block and previous block. We can check to see if the hash of the current block is still valid. So that would be if current block dot hash is not equal to the current block. Oops, I have one too many R's here. So current block dot calculate hash. So remember I said if the information within the block is not changed, then it means that the calculate hash is always going to be the same. But once the data within it changes, then it means that the hash will change. So we can just check for that and return false here. Okay, so that's our first check. The second check is going to be if we want to check that the block points to the correct previous block. So you say current block dot previous hash is not equals to previous block dot hash. Pretty straightforward here. And if that's the case, we return false as well. But if all these pass, let me just shift tab here so that makes it cleaner. And if all this passes, then we just simply want to return true here. And this will be our validity check. All right. So I'm also going to copy and paste a test for this as well. So we will have this. This is test 2. So I'll go ahead and just comment this out so we don't show this again. Maybe clear the console, a bit cleaner. And in here, what we're doing is that we're first checking if the blockchain is valid before we tamper with it, right? So we'll be going down, is chain valid? And maybe comment this out for now so that we can test that. So node main.js, yeah. Before tampering is true because we haven't tampered with it yet. So the validity passes. But now, if I'm to change the data within it, say I'll change amount 10 to 1,000 because I want to make myself rich, then let's see if that would pass the validity test or not. Boom. Okay, so we have false here. First is true because it's this one. Yep. And then the false showing that the second test, when after it got tampered, is not true. And some people might say that, what if you change the hash of the block? Would that pass? Let's see. Nope. Changing the block breaks the entire, changing the hash breaks the entire chain. So that also doesn't work. And here now we have succeeded in creating a simple blockchain, but it is still far from what Bitcoin is like, you know, or the other cryptocurrency. So blockchains deal with transactions, and hence we need to add some sort of transaction onto a block. And two, mining blocks, which is creating a block, should not be easy, and hence a difficulty level for mining needs to be in place. Three, since mining blocks are made harder, mining rewards needs to be given out to the people who mine these blocks. And also, there has to be way more validations than just this to make a blockchain more secure. But because we don't have a lot of time, I will show you what a blockchain with all these features added look like. So here I have BB coin, and this is the blocks on a chain. Each block, each card represents a block. We have the genesis block here, hash of previous block, and nonce. Nonce is an arbitrary number that when a hash is being mined, then it means it would take about 50 times for this hash to be shown, right? And inside the first block, we have mine wallet, which is the address that it was sent to from the system, which is and the amount that was sent is 100, which is the mining reward. You can go ahead and create a new transaction. So here, right now, we have my address. I can send this to, let's say, Shell, and I'll send 100 BB coins, and I'll send also to, just my pet, send 1,000 BB coins, or maybe 500, not too much, yeah. And when we view our pending transactions, we have all these here, but since we want to see it added to the block, let's do it in here. So I'll start mining, and boom, a new block is added, and within the block, 3 transactions. Michelle was sent to Michelle, was sent to Ponyo, and a reward of 100 was sent to me. But we can also change the settings and make the difficulty 4, which blockchain usually is, Bitcoin is on. I'll make the mining reward 1,000. So if I'm to create another transaction and say I want to give this to charity, and since the reward is 1,000, I want to give all that reward to charity, I'll just sign and create this, go back to our pending transactions, and you'll see here that we have this in the chain. Let's start mining. Boom. So right now, the difficulty has been set, and it took about 949 times to do that. So it means that it's much harder for the system to do. You keep mining, it would take different times, and a new block will be added. And that's simply my BB coin here. So now that we've seen how to build a blockchain and I've shown you what BB coin is like, maybe there are some additional features I would like to add. So what is there to improve? Security, security, and security. You know, blockchain needs to be way more secure. There has to be validations in place. And the fact that my current blockchain does not have a balance check. So I can send any amount of money without it checking my balance. I think that needs to be included as well later on. But for now, that's all it is. Blockchains are quite hard to understand in the beginning, but as you build a blockchain, it becomes a lot fun, and you will start to understand the in and out of it. And if you want to discuss more about blockchains with me, please feel free to reach out to me. And so my social media addresses are here. You can also get my GitHub repo for the BB coin, and my GitHub handle is Bilaal Lucas, so please follow me. Yes, and thank you very much. Thank you for watching, and I hope to see you another time.
Thank you, Bilaal. And after another quick break, Maya will be talking about machine learning, the Terminator, and human emotions. Stay tuned.
Hello, hello. Can you hear me? Hello? Can you hear me? Thank you. Okay. Can I try the YouTube too? Yeah, I will start.
Aya, we can hear you perfectly.
How about this? Okay. Okay. start. Hello, everyone. My name is, just a moment, please. Is this all right?
Perfect.
Hello, thank you. Hello, everyone. My name is Maya Shinagawa. Today, I'd like to make a presentation for those who don't like to talk about difficult topics. Before I begin, please let me introduce myself. I was born in Kobe City, Hyogo Prefecture, and grew up in Kobe until I graduated from university. At university, I majored in sociology. I currently work in the service field and don't use the computer very often. Now, I'd like to tell you briefly why I am here at Chrysalis. There are 3 reasons why I wanted to study programming. The first is there is always an answer in programming. When I was providing service at work, I am always thinking about what is the best service for the customer. However, only the customer knows that the answer, whether the service was correct or not. Although programming stopped working if just one letter is wrong. Receiving the answer was the new and exciting experience for me. Secondly, that is because I saw how software enriched our lives. Third reason is that I saw that learning programming would be a chance I want to take. That's why I am here. Today, I will talk about machine learning. Machine learning is a very difficult topic for me. I want to give a presentation to people who are not interested in machine learning. I won't talk about difficult topic, so please relax and enjoy my presentation. It took me a while to introduce myself. Let's begin. Here is the outline of my presentation today. Overview of machine learning, natural language processing, and NLP and human emotion. First, I'd like to talk about the overview of machine learning. As you know, many robots have been depicted in movie and anime. I have listed all the robots that I can think of. Do you know them all? In many cases, robots have helped humans and saved the planet. However, there is one movie that I had made me fear robots. It is this movie, The Terminator. I saw this movie when I was a child, and I remember it was very scary. I'm sorry if you don't like scary scenes. This is the scene. Excuse me. The scene below is Judgment Day, which is depicted as 1997 in this movie. This is the scene where robots with artificial intelligence and humans started nuclear war and killed the most of humanity. Fortunately, such a day did not come in 1997. Yes, we are still alive in 2021. But we can't rest easy. The future of our planet may change if you don't learn about machine learning and train them all. Now is the time to learn it. Are you ready? Let's start. In 1956, John McCarthy, a professor of math at Dartmouth College, named machine that is like humans, artificial intelligence. With the establishment of the concept of artificial intelligence and the definition of the term, it was recognized around the world and the research became more active. It is said that AI has had a series of booms. The first boom occurred in 1960s. At that time, AI could do simple games and puzzles. It used a technology called reasoning and exploration to find a pattern of solution based on the condition. However, it was not able to solve problems with complex intertwined factors, and the limit of its performance became apparent. The next boom came in 1980s when expert systems were developed to teach AI the specialized knowledge needed by experts to solve problems. Many companies introduced these expert systems into their business systems, and they are still in use today. However, it was more difficult than expected to make expert systems remember information that is like common knowledge for humans. And then we are now living in the third AI boom. Let's take a look at some of the keywords related to AI that are currently in the spotlight. I'd like to introduce a few keywords. The first one is AI. AI stands for artificial intelligence and is broad concept. AI is good at categorizing information, so it can streamline processing based on the information it obtains. On the other hand, it is not good at creating new rules from scratch and producing output. If the amount of information given by human is small or uneven, it cannot produce a correct output. Next, machine learning is a technology in which the machine itself analyzes the input information. Think like human brain, finds the rules and regulations, and returns more output than the input. Using this technology, the information obtained from the input can be turned into the rules, and appropriate output can be produced for unknown data. Next, neural networks. This uses layer of neural networks modeled the nerves of the human brain to enhance the analysis and learning of data. Next, deep learning is a technology in which a computer automatically discovers its features and patterns from raw data that has not been tempered by humans. Machine learning and deep learning are sometimes compared and contrasted. This is because in machine learning, humans process the data so that the machine can derive accurate output. While in deep learning, the computer can find the features and patterns in the data without processing it. This technology is also used as one of the algorithms in the neural network I mentioned earlier. Finally, the singularity. This term refers to the point in time when AI and other technologies will be able to produce intelligence smarter than humans. It has been proposed that AI will be as intelligent as humans in 2029, and that the singularity will come in 2045. However, due to the pandemic, it is said that IT technology has advanced for 10 years. The singularity may come sooner than predicted. Let's take a look at diagram of relationship between the 5 keywords I just told you about. The term AI is broadly defined as a concept in terms of intelligent machines. Machine learning is a core technology within the concept of AI, and within that, there are neural networks as one type of machine learning, and deep learning as one type of neural network algorithm. With further research, will the singularity become a reality someday? You may have seen her on the TVs, on TV programs. Her name is Sophia. She is a robot that can talk to humans with expressions. Recently, the Hong Kong robotic company that is developing Sophia announced that it plans to mass produce Sophia in response to a coronavirus and plans to sell thousands of units in the first half of 2021 this year. Here are the 5 most shocking phrases Sophia spoke. It is very scary. Am I the only one who imagines a mass-produced Terminator is going to be released into the world? There are various types of machine learning, but today I'd like to talk about a category of natural language processing within machine learning, because I want to talk about machine learning and humans' emotions. Natural language refers to the language that people use in their daily lives. We use this term to distinguish from programming language. Computers, in principle, can only handle numbers. So how does the computer handle language? Each word is assigned a code, which is a group of numbers, and that alone is a huge amount of data. In addition, when those words are combined to form sentences, the number of combinations becomes infinite. Here is a diagram of the pre-processing provided by Google. Neural language processing involved a lot of pre-processing, such as separating sentences into words, taking out comma, period, and remove articles that do not make sense in a sentence of other things. After this pre-processing, the features of each word are quantified to compress the amount of data in the text by making the text numerically tractable. I told you that I would not talk about anything difficult today. I have displayed this diagram to thank the researchers along with you. This is because new words are created every day. One word can have multiple meanings, and above all, they are ambiguous. Let me also tell you that there are 2 concepts in NLP. NLU is understanding, and it is also input for AI. And NLG is a generation. It is output for AI. You may already be familiar with NLP technology as it is being used in various services and products. Here are a few. Let's imagine each one has different kind of input and output. For example, spoken sentences, written sentences, and so on. Some robots are already working like humans' friends, sometimes telling jokes, sometimes talking to each other. The next topic will be about emotion. I have been talking about machines, but I like to talk a little about humans. Humans have a wide range of emotions, which are said to have become even more complex in the age of social networks. Humans are creatures that get caught up in their emotions. Some emotions get in the way and prevent us from doing what we could always do, which is to pay less attention. I'm sure we have all experienced such a situation before. But we do our best to express our emotions through facial expressions, gestures, and words. Among other things, our emotions are expressed in words. In the written words, we express our emotion in minute fluctuations of expression. In spoken language, our emotions are expressed in the tone, pitch, and the speed of our voice. I think we can all agree. I think we can all agree that we are not always the same, and that is why human beings are so wonderful. Then, how does AI express our emotions? There is one thing I like to share with you. Yes, as you know, it is a conversation of machines. It is so amazing. It is a commercial video made by AI developed by Sonantic. Sonantic is providing solutions to put emotions into AI's voice. You can try a demo on their website and feel the differences of AI voice which was put emotions. Then I like to show you the code to analyze my voices. Here is the file that I recorded my voice, and when I put into the data here, and then I could receive the data like this. There is an API to analyze our emotions like this. I'd like to introduce a company which name is Empath. Empath is a company that provides services and products that use AI-based emotion analysis technologies. The technology to analyze emotion from voice data without relying on language is attracting attention from around the world. Now I'd like to give a simple, I gave you the simple demonstration using the web API published by Empath. And also, I'd like to introduce an app called Mute that was released late last year. Have you ever heard of the term journaling? Journaling, also known as written meditation, is a popular method in Europe and the US to regulate your mind by writing down the many emotions that arise in your busy life. This app, which is called an AI journaling app, uses a method of categorizing and organizing information, which AI is good at. It analyzes human input of mood, and emotions and gives a visual feedback. 81% of users who use this app said that it helps them discover a new self. It seems to have given users new discoveries that they themselves were not aware of. They themselves were not aware of. I think this is a familiar example of how AI can heal the spirit that is tired from the influence of an SNS and the coronavirus. Today, humans are talking to machines through a variety of functions and services. I feel that the day when machines will be able to enrich our minds and protect our lives is just around the corner. When I heard the word machine, I imagined only the horrible Terminator. However, machines are now trying to understand human language and emotions, expressing their feelings to reach humans' heart and healing humans' being. The machine I fear may approaching to Doraemon instead of Terminator. Thank you for listening. I'm sorry. Yeah, I like to. Thank you for listening. I like to be a friend of Doraemon someday. Thank you.
Thank you very much, Maya. And this is the midpoint of our event. We'll take an intermission here and we'll be back at 5 with Cesca, diving deep into the inner works of JavaScript arrays.
Hello, everyone. My name is Francesca Marino, and I'm going to be talking to you today about JavaScript arrays under the hood. So, first off, who am I? All right, well, as I said, my name is Francesca. I'm 30 years old. I'm studying at a bootcamp in Tokyo called Chrysalis, and I'm learning mainly JavaScript. And then if I were to describe what kind of programmer I am, I'd say I was a scribe. Yeah. Oh, wait, scribe. What do I mean by that? Well, you can kind of, in my point of view, divide programmers into two types. You have the scribe and the conjurer. So scribes, they tend to be methodical, their code is very organized, and they generally do a lot of detailed research before going into any kind of implementation. On the other hand, conjurers, they're much more biased towards action, so they really focus on getting some working code first, and then after that, then they worry about understanding the ins and outs of that code. Okay, so now I'm talking about arrays, but let's just go to the absolute basics, array versus object. And these little asterisks are because JavaScript, for people who might not be familiar with it, arrays are objects, but they're kind of special, which is what I'm going to go into in this topic. But before we go into the specialness, let's just kind of look at what they are basically in JavaScript. So for arrays, they're indicated by the square brackets, and then you have the elements inside. The way you access those elements is by going to the index position, and that gets you the element. Then for objects, they're indicated by the curly braces, and then inside you have the key value pairs. And the way you access them is by looking at the key, and that gets you the value, like so. All right, so let's get started. Oops, a for in loop. All right, so where did this all start? Basically, when I was very, very, very beginner level learning programming, I made kind of a mistake. Or was it a mistake? Basically, I was working with an array, and I wanted to console log the elements of that array so I could double check what was inside it. And as you might have guessed from this slide, I used a for in loop. So let's get started. In the beginning, a newbie, me, made a mistake. So I have this array, and it has A, B, C, D, E in it. Of course, at the time, I think I just wanted to confirm that, so I just wanted to console log it. I used a for loop. All right, let's console log it, and then I printed it, and I got A, B, C, D, E. Okay, great. But wait a minute. I used a for in loop. And I thought we were taught that for in loops are for objects. And if you want to work with an array, you use a for of loop. Okay, but here I just used a for in loop, and it still printed out everything. Huh? What? Okay, well, being a scribe, that starts me thinking, all right, I need to get to the bottom of this. So I'm going to kind of be your guide down the rabbit hole of experimentation I went through. All right, so to start my experiment, I initialized an object, an array with empty spots. In my object, I have keys 0, 1, 2, 5, and I made just random values. And the array, I just initialized it as an empty array. And then the array with empty spots, I initialized it partly because I'm going to use this for comparison later on, and partly because I didn't actually know what would show up in a console log if I had empty spots. So let's see what prints out in the console for that. All right, well, the object looks pretty much like what we would expect. The array looks like what we would expect. And this array with empty spots prints out with empty times 3. Okay, well, now I know what to expect consoling an empty array, or an array with empty spots. All right, so now we've started the baseline of our experiment. Let's continue. All right, so that empty array that we initialized, let's fill it out. But let's fill it out with the mistake that started me on this journey with a for in loop. And we're going to use the object that we created as well. So for every key in that object that we created, we're going to kind of treat this array as an object, as we would treat a normal object, and fill it up with key value pairs. All right, so now let's console log this array that we've just kind of filled out. Oh, hi there, what's empty times 2 up? Wait a minute, that looks really familiar. In fact, it looks like exactly the same syntax and format that the array with empty spots that we printed out earlier. Okay then, so even though we used the for in loop and treated it like an object and initialized it with key value pairs, it's just showing up the same as a plain old array. Okay, well, that's very interesting. It looks like a duck and it quacks like a duck. All right. So we filled it out from an object and it printed out the same as the array with empty spots that we created for comparison. It's an array, right? So will a for of loop still work on it? Let's find out. So for each element of our array, let's just console log it and see if the program explodes or not, or if it just console logs stuff for us. Yeah. Okay. Hi there, what's, and then the empty spots. Okay. Well, it must be a duck then, or an array. All right, well, we're kind of building our kind of baseline of proofs, as it were. Let's continue. In fact, let's start trying to trick JavaScript now. Okay, so now we're just going to start ourselves off with an array. We'll just have it our test array. It has do, re, mi in it. We'll console log it. And we're also going to console log at index position 3. Now, as you know, index positions start at 0. So right now, the array only has 0, 1, 2. There is no 3. And I just want to know what is going to console for an index position that doesn't exist. All right, so let's see what comes out of this. Okay, so console logging the array gets us do, re, mi. And then the index position 3 gives us undefined. Okay, well, no real surprises there. All right, let's continue. Now let's get really experimental. So since we do know that technically arrays are objects, let's treat it like an object and try to add a key value pair. So we're going to have our test array at the key owl equal to Merlin. And we'll console log our array and see what we get. What do you think we'll get? I'll give you just a moment to think. Okay, so what do we get? We get do, re, mi. Wait a minute, what? Owl colon Merlin. Okay. This is really weird looking because as you see here, it still has the square brackets. And square brackets are only used when you're displaying arrays. And arrays don't have key value pairs, but this one does. So JavaScript still, in JavaScript's mind, this is an array. Okay, so yeah. So what is this owl colon Merlin? All right, well, is it now the new index 3 value somehow? Well, we know we console logged it before we did all this experimentation. It prints out undefined. So what happens if we print out index position 3 now? undefined. Okay, so there's nothing at index position 3, but I mean, as we can see with our eyes, there is something here after me. Okay, so what if we try to look at that value as if it was an object? Okay, we'll console log this and get, oh, we get Merlin. Okay, so this is now a weird array that also has a key value pair in it now. Okay, well, let's continue experimenting. All right, so let's kind of do this in 2 ways. We will try to print these keys with for in, and we'll try to print the elements with for of. And when I say keys, well, what do I mean? I'll let you kind of come up with some guesses first, and then I'll show you. All right, so just give you a moment, think. So we're doing for in, and we want to console log x, and usually this would be the key because this is treating it as an object. And then for the for of loop, that should just print the elements of the array. Okay, well, what do we get? All right, we get 0, 1, 2, owl. Okay. All right, so those are the keys. Let's print the elements. Do, re, mi. Wait a minute, where's Merlin? Where did Merlin go? What? What just happened? Did we trick JavaScript? I guess so. Okay, so let's start really talking about what's going on behind the scenes here. So what's the best way to figure things out? As described. Well, we want to do digging to the documentation. All right, MDN, I'm counting on you. Counting on you. All right, so here's what MDN has to say. The JavaScript array class is a global object that is used in the construction of arrays, which are high-level list-like objects. Well, I mean, that's a nice definition, and it says that it's an object, and we do know that in JavaScript, arrays are objects. That's nice, but this definition right here doesn't really explain the reason why our experiment turned out the way it did. Okay, so it's okay. We're not going to give up. Or at least I didn't give up because I'm really stubborn. So let's see what MDN has to say about objects. The object class represents one of JavaScript's data types and is used to store various keyed collections and more complex entities. Okay, again, that's a nice definition, but it doesn't answer or explain why our experiment turned out the way it did. Well, shoot. What do we do now? It's okay. Don't panic. So, oh no, MDN didn't help. We're going to start panicking. No, we're not going to start panicking. We are going to go to ECMAScript. Sorry, MDN. You're really useful a lot of the time, but unfortunately not in this case. So here's what ECMAScript is. ECMAScript, it's the scripting language that forms the basis of JavaScript and is standardized by an organization called ECMAScript International. So kind of to give you some more context about that, it's basically the detailed rules for how JavaScript works. Okay, that sounds really promising. That sounds like maybe if we kind of pursue this, we'll get some real answers. All right. So what does ECMAScript have to say about arrays? Let's see. All right, array objects are exotic objects that give special treatment to a certain class of property names. Okay, so, I mean, it's telling us that they're objects. Oh, wait a minute. They're exotic objects. What the heck does that mean? MDN didn't say anything about exotic. All right, let's keep digging. Let's keep digging. Brace yourselves. It's time for a wall of text. Okay, ECMAScript. An array object is an exotic object that gives special treatment to an array index property keys C6.1.7. I'm sorry, what? Huh? Oh, yeah, that's a giant mouthful. Let's kind of try and kind of parse that out to be more easily digested. Okay, so really, an object is an array exotic object, or simply an array object, if its define own property internal method uses the following implementation and its other essential internal methods use the definitions found in 10.1. Okay, its define own property uses the following implementation. Okay, we're getting leads each time we dig a little more. So let's dig into that following implementation. Also, as a side note, the other essential internal methods use the definitions found, blah, blah, blah. That's just the definitions used for like all objects. So basically what this is saying, this special define own property, if it does these following implementations, that makes it an array. And then we just do the normal stuff for the object. So the normal stuff for the object we don't really care about. Let's just focus on the define own property. Okay, so define own property. I feel like we're on the right track here. Getting close to some answers maybe. All right, so define own property. The define own property internal method of an array exotic object, just call it A, takes arguments P, a property key, and a disk or a property descriptor. And these are the steps that happen when you call it. So first, it asserts, is property key P? Yes, it's true. It asserts that, it establishes that. Then, if P is length, it returns set the array length. Okay. If P is an array index, then it does a bunch of stuff and it returns true. Cool. And then also return ordinary define own property, which is that like other implementation stuff for normal objects. Cool. So yeah, these are the things that we care about that make it special or exotic compared to a regular object. Oh, and don't worry, I'm not just going to leave you hanging with do a bunch of other stuff. Let's kind of talk about what that other stuff is. Okay, so, all right, do a bunch of other stuff. Let's boil that down. Basically, it's a bunch of complicated steps that set up the special index position numbers that enable us to use the array at index blah, 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 like this. And one of the things that it is basically really useful for like doing math with the index positions is that it initializes, like the first one is always 0, and it makes sure that the index positions are never negative numbers. Okay then, cool. So because of it doing this, we can manipulate these fancy exotic object arrays in ways that we can't with ordinary objects. Sorry, ordinary objects, you have your place, but we're really interested in the exotic ones right now. Okay, so now that we know that, let's get into some array specifics, or rather, let's get exotic. Okay, which array specifics? Specifically. All right, we're going to look at array.isArray. We're going to look at array.length. We're going to look at array.prototype.map. Okay, let's go into these. So for array.isArray. All right, ECMAScript, you've been really useful so far. What do you have to say about this one? Okay, when the isArray method is called, the following steps are taken. Ooh, what are they? Return isArray, arg. Thanks. I mean, that's what we were asking. Why are you just saying that it returns if it's an... Okay, well, fine. Let's do some more digging. what is this is array? Okay. First, it checks, is arg an object? Because as we know, arrays are objects. So if this argument isn't even an object, then there's no point in checking to see if it's an exotic object or it's an array or it's anything, because that just eliminates anything. So after it confirms that, then is arg an array exotic object? If yes, okay, return true. Sweet. Okay, this is really simple looking, but I really want to make this point clear. The main distinction for arrays being special is the fact that it's an exotic object. And that's why this is array. All it's checking is first, is it an object? And then, is it an exotic object? So yeah, that's really the defining characteristic. Cool. Okay, then. Let's go to the next one. Array.length. All right, ECMAScript, what do you got for us now? The length property of an array instance is a data property whose value is always numerically greater than the name of every configurable on property whose name is an array index. Okay, okay. What else do you have to say, ECMAScript? All right, the length property initially has the attributes writable true, enumerable false, configurable false. Okay, okay. So it's basically how long the array is. But one thing that's very important here is this writable true, because it means you can do things like this, array.length equals 0, or maybe array.length equals array.length minus 1. Now, I'm going to say this right now. If you don't fully understand what's going on here, do not do this. You will not like your results. Now, if you have the same personality as I do, you'll be like, yeah, okay, I'm going to go try that, because why are you telling me that? Don't worry, I'm going to take care of that for you. Let's look at what happens when you do that. So the writable length property. All right, so we've got our array. This is a test. Now let's see what happens when we do array.length is 0 and console log it. Just a second. Oops, you have now deleted everything that was inside your array, and it's gone. It's gone. So I hope that's what you were aiming for, because you can't get it back. So, I mean, it's not that you're going to cause anything to crash necessarily by doing this, but unless your goal was an empty array, don't do this. All right, how about the other one? You can probably, after seeing this, kind of make some guesses. So here's another test. Now we're going to do array.length equals another array.length minus 1, and we'll console log it. What do you think? Okay, here's what it is. Oh, oops. What happened to that third element? It's gone. It's not hiding somewhere. No, it's just gone. So again, unless this is what you wanted to have happen, don't do this. Also, another interesting aspect of this, another array.length equals .length minus 1, that's basically what the .pop method is doing behind the scenes. So now you also kind of know a little bit more about the pop method. Okay, so let's go on to the .map one. All right, and it takes a callback function, this arg. Okay, okay. ECMAScript, what have you got for us? Okay, well, a lot of things we actually already know about what map does, which isn't why we're looking at this. We want to know how it's doing it with respect to arrays. Okay, so it says, wait a sec. The map function is intentionally generic. It doesn't require that it's this value be an array object. So it can actually be transferred to other kind of objects for use as a method. Oh, wait, that's not really array specific after all. Huh. All right, well, I don't know about you guys, but the inner scribe in me right now is thinking, oh, now what? I really want to kind of see what other objects we can use .map on. But that is another rabbit hole to go down another day. Right now, we just care about it in terms of an array, and it doesn't do anything special with the terms to an array. So, okay then. Make a mental note to do that rabbit hole another day. Okay, so what can we do with all of this? All right. So basically, what was the point of this? Learning. Maybe you're not satisfied by that, I don't know. But so let me kind of sum it up a little. All right, so we knew that arrays are objects, but now we found out what makes them special is that they are exotic objects. And we kind of delved a bit into what's happening behind the scenes that enables that classification as an exotic object, and then how some of the specific array-specific methods actually work. So it kind of broadened our understanding. And it also, with the experimentation part that we did at the beginning, now knowing what we know about that they're exotic objects and what's happening behind the scenes, we can kind of look back on those manipulations we made and kind of start thinking about what else we can do now knowing what we've learned. And another thing, so I went into MDN and ECMAScript. Well, basically, I guess I just want to say, don't be afraid of ECMAScript. It's very dense and very wordy, and a lot of the stuff is like that wall of text that I showed. But with digging, we actually got the answers that we were looking for. So if MDN doesn't really answer your questions, don't be afraid to go digging in ECMAScript. And also, even if you kind of maybe view yourself as a conjurer type programmer, kind of let your inner scribe out sometimes, because you can find out some really interesting quirks about the languages that you're programming in. Although, to the scribes out there, and I am giving this advice to myself, I'm not going to say whether I followed it or not, be careful about those rabbit holes, because like the .map one earlier, that's really interesting about how it can be applied to other things, but that would be another whole rabbit hole to go down. So let your inner scribe out, but kind of keep an eye on them. Yeah, that's pretty much that. I do want to thank my sources and my credits. These templates for these slides are from Slides Carnival, and the research that I did was from the MDN web docs and ECMAScript's documentation. All right, thank you all for listening. And if you have any questions, you can find me on GitHub or you can send me an email. And I hope this was as fascinating to you as it is to me. Thank you very much.
Thank you, Cesca. And after a short break, we'll have Jeff talking about simulating a physical system in this virtual village of ours.
Okay, so it's about time, and I will share my screen and start our next part. So let's get started and talk about physics engines in the lab. First, a little bit information about myself. I'm a physics graduate, and I'm also a software sales before. And yeah, I'm learning in Chrysalis and to become a software engineer. So I hope I can use my knowledge in physics and also my understanding of softwares to sell the idea of physics engine to you today. Before we start, let's take a look at this video. Very satisfying, right? Isn't it? But I believe all of us can tell that there's something wrong with this video. So everything happens in the video. It doesn't follow the real world physics rule. So probably you can tell now, like, what is the purpose of a physics engine and why do we need that in creating some simulations? So for today's talk, it will be separated into 3 parts. First part will be a basic introduction to the physics engine. And the second part, we will be introducing a JavaScript library called meta.js. And we'll be using that to create a small game. The last part is about some applications and more of its future usages. So let's get started. What exactly is a physics engine? So here is an animation from Wikipedia. So for physics engine, we have talked about the usage is to simulate the real world when we are creating some objects in our softwares. So if you take a look at the number 1 simulation, we have a sphere and a slope. Now we want to make it more like the real world. So first, we need as one boundary is that we need to add gravity. So in number 2, we can see that the sphere will fall to the ground. But there's something strange because it goes through the slope. So we need to add another boundary, which is the rigid body, so that our software knows when objects will have edge, and when their edges touch each other, they should not move through that. So this is the definition of a rigid body. So if we take a look at the number 3 animation, the sphere falls down, but when it goes through the slope, it's still a bit strange. It's not very much like the real world. So we need to add one more boundary, which is the friction. So when objects touch each other, they should interact with each other a little bit. So exactly as what you can see in number 4, when it falls down, it rotates a little bit. So physics engine is all about this. Boundaries are created for the objects in our virtual world. For some general applications, physics engines is a lot used in gaming, but apart from that, we can also use that for simulation, for researches, or some computer-generated imagery. For example, Pixars use a lot of physics engine in creating their animations. Here is another example in simulation or CGI. So if we take a look at this process, we're using physics engine to create a simulation of baking a cookie. So the red part is we do it in higher temperature, and the green part is a lower temperature. So basically it shows that if we do it in a higher temperature, the cookie will become solid very fast. And if we do it in a lower temperature, it may float and the cookie will be a larger pile. So the good thing of physics engine is that in creating this kind of animation, we don't need to specify each part of the object, like how fast they go and which direction the cookie dough should go. We only need to define the physics rule and let all the parts or like the particle in the cookie follow the physics rule and do their job. So it's actually an easier way to create animation and simulation with this. Physics engine has been long in the industry, and there's a lot of different libraries and engines out there. One famous package is called PhysX. It's developed by NVIDIA, and it's now open sourced. So its applications is largely in gaming. So to simulate some sceneries like when you tear a cloth or paper, you can see on the pointer. You can see it here. When you tear a paper apart, usually the boundary is not, it's a little bit random. So you cannot really define how the boundary goes like beforehand. It only happens when you apply the force on the paper and you will know where the boundary will go. So here in such a complicated situation, we need to specify the physics rule there rather than define how the line will go. And in a similar way, when we are simulating smoke, you can see from this picture, there's a lot of small particles going in the air. So it's basically impossible for programmers to define a route of these particles. Rather than that, we will need to define how the air will interact with the particle and let them do their own job. Apart from gaming, we can also use physics engine in simulation. And one major application is called digital twin. So what is a digital twin? In short, digital twin is a virtual copy of anything in our real world, for example, a machine. And this digital twin, the purpose is that it's create as much like similar to the real world counterpart as possible. So for example, when scientists develop a robot, they might want to create a virtual one in software before actually create a hardware, because it's always easy to modify software than hardware. For example, in this video, we can simulate the mechanical arm and their movement to see how the machine will work if we design the robot in this way. And apart from robotics, it's also very useful in simulation training. So I guess you all know that in training a pilot, they need to first drive an airplane in a simulated environment before they go on a real airplane. So similarly in like manufacturing plants, when we are training a new worker to operate some dangerous machine, for example, in a chemical plant, we might want to create a simulated environment to train them. So in order to create that, we need to create a digital twin of the real machine that operates exactly the same as the real one. And in creating such a digital twin, I believe that the physics engine would be an important backbone in simulating the digital twin. So here is some basic introduction to the physics engine. And let's get to the second part of our talk about Meta.js. So this engine on the web, why do we need to put it on the web and how do we do that? So for game development and simulation, it has a long history and it's mainly developed in C++. For example, the PhysX and another popular library called Box2D, they're all in C++. But in recent 10 years, users have been moving from desktop apps to website and browsers more. So JavaScript has become a main developing language in the industry. So for developing physics engine, there are two ways of migrating them from C++ to JavaScript. One is to transcribe them. For example, the Box2D, they have transcribed it into JavaScript. Or you can create from scratch. So P2, Plan, and Meta.js are examples of this kind. They are creating in JavaScript from scratch. And the reason why I choose Meta.js is that because it's popular. It got 11K stars on GitHub. So it's easier for me to find resources out there. There's quite a lot of users out there. And it's very simple and very easy to use. So basically, it's a bunch of API that wraps the calculation of the physics rules with how the objects interact with each other. So we only need to care about the renderer and engine and those objects. So for renderer, it's an API that will manage all your objects on your screen, and it's called Canvas. And for engine, it manages all the interactions. For example, if you apply a force to an object, it will move in certain speed. That is calculated by the engine. So bear the two concepts in mind, we can start to build a small game with this. So I believe if you are of the same age of mine, you should have played a game called Angry Birds before. So we can create a simplified Angry Bird out of Meta.js today. Let's take a look at what we're going to create today. So here I have our code here, and we can render it in an HTML file. So I'll open this. So basically, we have an object, we can shoot them to some kind of targets. We do this. So this is a very basic version or simplified version of Angry Birds. So you can imagine that in order to create such a game, we need several steps. We need to create a world to contain these objects and create some objects in the world. And also we need to add some functions to deal with the action. So to explain the code, I separate this app into 4 parts. The first part is to create a world. So basically the canvas and the ground. Step 2, I will add the target here. Step 3, I will add the slingshot. Step 4, I will add the firing function. So please bear the 4 steps in mind, and we'll move to the code. Okay, so here I separate my code into 4 parts. And let me hide everything. Start from scratch. So for step 1, we need to create our world and ground. So here, so as I mentioned, the basic building block of this Meta.js would be the engine and renderer. So we will need to create an engine and a renderer. And also we need to start the engine and renderer at the end. So everything, like every object we want to add will be add in between these lines of code. We create engine, create render, and start them. And we will create a ground in between. So this Meta.js has a API to create objects. It's called bodies, and it contains all kinds of objects inside. Here I call the bodies with a rectangle object. So the ground is basically a rectangle with a certain size and certain position. And we add one more feature, is that the ground should be static. So no matter what kind of force applied on it, it will not move. And then we add this ground into our world. So the world is basically a container that links to our renderer. So we add the box into the renderer, it will show it. So we refresh the page. Okay, nothing special. We have just a rectangle here and it's not moving. The second step, we will add some targets. It's basically the same. So add some more rectangles, but it will be cumbersome if we create the rectangles one by one. So it also has another API called composites. It will create a bunch of objects for you. So we want a group of rectangles like a pyramid. So we define a pyramid of a certain size, and it uses a callback function to create rectangles inside the pyramid. And similarly, we add this into our world. We can see a bunch of rectangles created. Okay, so far so good. Next, we will be creating the ball and sling. So the ball is just a circle, as you can imagine, but something special about that is it has a constraint. So it cannot move away from its original point too far, or there will be a force to drag that back. So the force is actually the stiffness defined here. So if the stiffness is higher, the force that drag it back will be stronger. And we create a stiffness here, and then we attach the ball to the constraint. And again, we add this newly created object to the world. Here, we get the ball, and it's on a spring-like stuff. But at this point, we still can't interact with our app because we don't have an event listener to keep track of our mouse interaction. So another object, it's called the mouse. It's also from the Meta.js API. If we create a mouse and a mouse constraint, this object will act as an event listener to our mouse. So the user can interact with our app now. So it will work like this. We can click on the ball and drag it to move the ball. Also, we can interact with our rectangles as well. We can move the rectangles into different places. But here, if we try to fire the ball, it does not go because we haven't defined the firing function yet. The ball is always constrained by the constraint we have defined. So let's go through the function that fires the ball. It's a little bit longer, but it's not as hard to understand. So first, we define a firing variable. First is false. And we add another event listener on our mouse constraint. So if the user drags and release the mouse, so it's called an end drag event, we will set the firing to true. And if the firing is true and the ball is a little bit away from its original point, so this is just to calculate its position, is a little bit away from its original point, we will fire the ball. And the way we do it is to create one new ball, and we add the new ball to this world, and we attach the new ball to our constraint. So by this step, when we add the new ball to our sling, the old ball will lose its connection with the sling, so it will fly by itself. So we save this again. Boom. So now it fires. So basically how it works is that if we release, it's set to be true. And when the ball is moving a little bit away from the original point, it loses connection to the string and it flies away. Yeah, so this is a very basic app created with Meta.js. And you can see that everything is defined with APIs. For example, world, buddies. So it's not actually that hard to learn. Okay, finally, some more applications to Physics Engine, especially in the web. So how can we use that in the future or like other than gaming? Here I have an example. This can also be used in UI design or some computer graphics. This example is from the Meta.js documentation. So the guy has used this. He's like I think a graphic designer. So he created his own personal website with a lot of physics engine objects. So you can see a lot of balls moving here and there. And if the user try to move, you can see there's a kind of a force applying and move the balls into right direction. So actually physics engine can be used in creating very cool UIs. Here's another example, but for time's sake, let me skip now. And also for gaming, here I do not have some solid examples, but let me guide you through some trends of gaming. So as you know, gaming is still mainly happen in our desktop environment. But in recent years, there are more and more gaming moving from desktop to web as well. And the trend can be seen from the recent new supporting from our game developing engines. So now Unity and Unreal Engine, two main developing platforms, they now support HTML5 through WebGL or Web Graphic Library. So what it means is that for game developers, they don't need to create another version of their game for web. They just need to export from Unity or Unreal Engine. They can create a web version of their games. Another trend is that we now have more and more joinable streamings possible. And this is led by Google Stadia. It's called State Share. So what happening here is that when you're watching a streaming from other gamers, you can actually join their game in the exactly same state. And this is a very interesting thing for me because I'm not as good in gaming, and sometimes I just couldn't get through some harder stages. But if I'm watching someone else playing that, and I find that stage interesting, I can also join in the same state, so I can enjoy that part of the game as well. So to do this, it's also happening in the web as well. So for this kind of trend, we can foresee that in the future, there will be more and more gaming available in the web. And Physics Engine will have more application in the web as well, I believe. And last but not least, when you see those objects moving around, you might have related this to your high school physics. So like your high school teacher might have asked you, this object will move with certain speed and it collide with another object. And what is the speed of the other object? So this can be confusing as a student if you cannot picture what's happening and you're just being asked to calculate a lot of math. So a smart guy actually created a learning tool with Meta.js. So for example, if a student want to calculate momentum, you can go through this website and do some animation like this. So I have one object and the other object with certain speed. After they collide, they will change the speed and move to different directions. So this would be a very good learning tool for students, I believe, and not for problem solving only, and also for experiments. So before they actually go into the lab, they can kind of picture what will be happening in the web. So I believe this will make their learning a better and more interesting experience. So here would be a conclusion of my talk. So Physics Engine, not only in gaming, but also in design and some more education scenarios. And I hope you enjoyed my talk. If you're interested in more about Traceability Engine, you can find me at CYJF on GitHub, LinkedIn, and Instagram. Here is a QR code on the Angry Bird like game I showed you today. If you're interested to play around with the code, you can go to the GitHub and to find out. For today's slide, I also used Economos template. And this is a very good resource. I recommend this to you as well. So thank you for your time, and I hope you enjoyed the talk and learned something from me today.
Thank you, Jeff. And our next presentation is all about speed. So after a pit stop, we will be hitting the accelerator with Matt.
Imagine this scenario. You're on Google, searching for some elusive piece of information to finish a work assignment. You're flying through links, scanning pages, and moving quickly. And then you see it, a result that seems promising. It's just what you were searching for. You click the link, and nothing happens. A second goes by, then another, and another. It feels like an eternity. What do? You abandon the result and move on, making a mental note to avoid that site in the future. How about this scenario? You're online shopping. The site has tons of options. You click a few items that you'd like to compare before narrowing down your choices. But each product you try to look at is taking 3 to 4 seconds. It's taking so long that you're losing focus on the task. What do? You leave the site and spend your money elsewhere. In both of these scenarios, the site owners have failed the users. The site owners have lost traffic and potential customers because of something that was likely avoidable: slow page loading. Slow load times are frustrating for users. Slow load times can cause users to dislike a brand, no matter how great the site content is or how great the products are. My name is Matt, and in this presentation, I'll talk about how to boost your website's performance. I'll cover why website performance is important, how you can measure it, and how you can make your site faster. For a quick self-intro, my background is in management, sales, and project management. I worked in the finance and accounting industry for the last 5 years. And after graduating Code Chrysalis, I'm looking forward to exploring how my background in business and new tech skills can be put to good use as a software engineer. I chose the topic of page load speed because while it is a technical subject, it can have a big influence on the bottom line of a business. It has a direct impact on customer satisfaction and revenue. So let's expand on that. Why is page speed so important? Conversions, bounce rates, and search engine optimization. A conversion is a digital marketing term that refers to when a visitor to your site completes a desired goal. The desired goal could be signing up, making a purchase, watching a video, etc. Basically, a conversion occurs when the visitor changes from a passive visitor to an active visitor or customer. There was a study done by Deloitte that focused on some well-established brands with very high volume website traffic. The study measured changes in conversions given a 0.1 second increase in page speed. 0.1 seconds, the blink of an eye. The study found an 8% increase in conversions for retail store sites and a 10% increase in conversions for travel sites. 8 and 10%. Pretty amazing, right? In addition to conversions, the average order value also increased by 9.2% for the retail sites. That's the equivalent of receiving an additional month's worth of revenue, just for a 0.1 second increase in speed. So no matter what a conversion means on your site, don't underestimate the role that page load speed can have. The next is bounce rates. Bounce rate represents the percentage of visitors who enter the site and then leave or bounce, rather than continuing to view other pages. Our first scenario of the presentation, where the visitor clicked a slow link from Google and decided to leave the page, is an extreme example of a bounce. In that case, the visitor bounced before the page even loaded. Generally speaking, a low bounce rate means visitors are interacting with and spending time on the site. And a high bounce rate means they're leaving quickly and without interacting. The probability of a bounce increases 32% when page load time goes from 1 to 3 seconds, and it increases by 90% when the load time changes from 1 to 5 seconds. And some studies have shown that if your site takes 3 seconds or longer to load, you can expect 40% of visitors to abandon the page. That's almost half your traffic leaving before your page even loads. So page speed is definitely a factor when it comes to bounce rates. The third reason page load speed is important is SEO. Search engines want to give users what they're looking for: high-performing sites with low bounce rates. If you think back to the second scenario of the retail store with slow loading product pages, the visitor bounced, and that interaction shows Google that the slow site was not a good result. Page speed is a direct metric for SEO. And if the page speed results in bad user experience, that will also hurt the site's SEO ranking. At this point, I hope you're in agreement with me that a site's performance is critical. So what should you do about it? First, measure it. Get your baseline. Ideally, your site should load in 2 seconds or less. To measure your site, I recommend adding the Chrome extension, Lighthouse. Built by Google, it lets you audit your site's performance using Chrome's developer tools. And what's neat about Lighthouse is that you can simulate a desktop or mobile environment. And with mobile, whether the visitor is on a 3G or 4G network, so you can get a sense of how your page performs on all different types of networks and speeds. To measure, set your browser to incognito mode. Go to the site you want to audit and open the Chrome developer tools, and then select Lighthouse. You can choose mobile or desktop and run the audit by clicking the Generate Report button. And Lighthouse will give a score for each of 4 areas: performance, accessibility, best practices, and SEO. And for this presentation, we'll focus on the performance score. And there are another 6 metrics that make up that score. The first 4, first contentful paint, largest contentful paint, speed index, and cumulative layout shift, are concerned with the speed and behavior of elements as they become visible on the page. For example, how quickly does your first piece of content render or appear on the screen? If you, as a user, click something, go to a page, but you don't see anything happen, you wonder if it's working or not. So the first contentful paint is important because it signals to a user that your page is loading and that they should just wait. Also, do the elements shift around on the page as they load? That's what cumulative layout shift measures. This can be really frustrating if a user tries to click on a link or a button, but the page is shifting around while it's loading and they accidentally click the wrong thing. The last 2 metrics, time to interactive and total blocking time, measure how quickly your page becomes interactive. If you've ever been to a site that appears frozen and doesn't respond when you try to scroll or click a link, you know why these measures are important. And one thing to keep in mind while using Lighthouse is that you don't need to get hung up on any one metric or score. Lighthouse and any other audit tool is just that, a tool. They're trying to measure the experience for a visitor to your site, but the tools won't know your users better than you do. So you still need to think critically about the site from the perspective of your users. Determine what your users will perceive as fast and focus on that. For example, if the purpose of your site is to mainly convey information, focus on metrics that describe how quickly content gets loaded, such as largest contentful paint or speed index. Since users will be consuming information, it's important that the content gets rendered on the screen as quickly as possible. You can contrast that with a site that is meant to be very interactive. So improving on the interactivity measures would be a high priority in that case. You don't want to confuse or frustrate users who try to fill out a form or click a link and it doesn't respond. The last thing to mention about Lighthouse is that it provides a list of opportunities it identifies during the audit. These are opportunities that Lighthouse thinks you can use to make your site faster. And these can be a great starting point for making improvements. We won't cover the opportunities in this presentation, but I encourage you to play around with the Lighthouse audits, and you can get a sense of what types of suggestions it gives, such as the one shown here, removing unused JavaScript. Now, for the last section of the talk, we'll take a look at how to boost performance. I chose 4 strategies that address common reasons for slow performance: optimizing images, using a CDN, reducing HTTP requests, and prefetching. Perhaps the most common reason for slow performance is images. Images that are not optimized. They're the most requested asset type for most websites, and they usually take up more bandwidth than any other resource. So here's how to optimize your images. You can resize, choose the optimal file type, compress, and use lazy loading. So why do you need to resize? Well, you don't need a 4K picture for an image thumbnail. You should choose the right image size and quality to suit each situation. Let's say you have this image and you want to add it to your site. Its original size is around 1200 kilobytes, and it's 2000 by 3000 pixels. You decide you want to use it as a thumbnail image. Clearly, this high quality picture is overkill. So to resize it, just use a resizer. Here's one at reduceimages.com. You can drag your image into the top section, choose a new size and format in the center, click resize, and then download the image from the bottom. Very simple. And in this case, we made the new image 70% of the size of the original and 25% of the quality. Here's the result. The image went from 1200 kilobytes to 205 kilobytes. So almost 1/6 of the memory. And if you look at the quality, it's still pretty good. It should be more than sufficient to use as a thumbnail image. And in fact, you could probably even make it smaller. So the next way to reduce your image size is the file type. Different file types use different amounts of memory, but the general rule of thumb is this: use JPEG for images and PNG for graphics. It's that easy. The third is compression. And if you're using JavaScript, the chances are that you're using Webpack as well for bundling and minifying files. So to compress images, you can add a URL loader with a simple npm install, and then just modify your Webpack config file to include the URL loader. It's a small amount of code, and you can easily find out how to do it on Google. And this will compress the images to use even less memory. Lastly is lazy loading. Lazy loading refers to delaying loading until the images enter the viewport, as shown on the right. The default is eager loading, as shown on the left, in which all images will try to load, even if they're not shown on the viewport. So lazy loading only loads the image as it gets close to the viewport when the user is scrolling through the page. This will speed up your site, and it also saves your user from using their bandwidth to load what's potentially unnecessary if they don't scroll. So how do you implement it? All you do is you add the loading attribute with a value of lazy to your image tags in HTML. Again, super easy. So optimizing images will really boost your performance, and particularly on the rendering side. So next, let's talk about a CDN, or Content Delivery Network. And the purpose of a CDN is to reduce latency, which is the time it takes to fulfill requests. If your site will receive visitors from around the world, their geographical location could lead to a slow experience, because the farther away someone is from your server, the longer the request will take. That's where a CDN comes in. The CDN provider will cache or store your assets in strategic geographic locations around the world. And this will shorten the physical distance requests need to travel and save time for your users. So to set up a CDN, you should choose a CDN provider, register your site, create your CDN URL, and then change your code to point your assets to the CDN URL where they'll be served. And the CDN provider takes care of figuring out the closest server to provide the assets based on the user making the request. And the CDN will ensure that users throughout the world will experience minimum latency no matter where they're making requests from. The third way to speed up your site is to reduce HTTP requests. Every time your site needs a file, it will make a request to the server, which takes more time. To understand how many requests your site is making, you can use the network panel of the dev tools, and you can see how many requests the site is making and how long each one took. So this will give you a sense of where your site is currently at. And to reduce this number, you can minimize third-party scripts, and again, you can use Webpack. So third-party scripts can increase HTTP requests since they may involve additional requests that you're not actually making use of in your site. So being very deliberate about your third-party scripts and identifying if any are slowing down your site should be a factor when you decide which third-party scripts you decide to keep and which you should get rid of. You know, do you really need a whole Bootstrap library if you're just going to style a few buttons? And also, you can use, if you're using Webpack, it will bundle your scripts for you. So instead of making separate requests for each CSS and each JavaScript file that's a part of your site, bundling will let you make just one request for a bundled JS file and one for a CSS file. And another nice thing that Webpack does for you is it minifies your files. So minifying means removing anything that's useless to the machine. Comments, empty lines, white spaces, indentation, etc. These are necessary for humans to make code more readable, but waste space when the machine is interpreting it. So minifying strips those unnecessary portions from your code to make the files as small as possible. So the last strategy we'll talk about is prefetching. Now, prefetching can be a great resource if the user's or the visitor's behavior is fairly predictable. So if you know a user is going to land on a landing page and they're most likely going to click and go to some next page, prefetching can be a great asset in speeding up that, moving to that next page. So prefetching allows the browser to silently fetch resources for content that a visitor might access in the future. Here's what it looks like. So you load the original page, and then the browser finds any prefetch links. And in the background, it will fetch those required content to display those next pages, so that if a user does click on them, that content is already in the browser cache. And to implement it, again, it's very easy. You can add a rel attribute with the value prefetch to your link tag, for example. But before you go and add lots of prefetch tags throughout your site, consider the cost. If the prefetched resources don't get used, you've wasted bandwidth. So use it strategically when user behavior is predictable. And for example, Google often uses a prefetch for like the first one or two results from a search query, because it knows users are very likely to click on either the first or second result from a query, and that loads those results very quickly. So these 4 strategies are a great place to get started on your journey to making a faster site. Now, let's revisit our initial scenarios and imagine that the 2 site owners had implemented these strategies. And let's imagine that they had increased their site speed to the recommended target of 2 seconds to load. What would their outcomes have been like? Well, for the Google search, the visitor could quickly get the information they need and maybe bookmarks the site for the future. And for the retail scenario, the visitor might purchase a few products and maybe tells a friend about the site. So in the end, you would have delighted users and much better outcomes for the site owners, and everybody wins. So in closing, I hope this presentation has convinced you to invest in speeding up your website. And also, I hope it's given you the tools and the confidence to get started. Thank you so much for listening.
Thank you, Matt, and thank you everyone that tuned in. From Monday, CC18 and CCJ4 will have a month to build the senior project at Code Chrysalis. This project will be shared, it will be presented live on YouTube on May 6th. So save the day and see you there. Bye-bye.